Good morning. And because computer configurations rot magically while you're not using them, something I still am trying to wrap my head around. Some things may not be quite 100% correct on the audio front. Seems like audio is always the culprit. I'm not sure why. But yeah, hopefully that's pretty good. No, that's a green screen. And that's an image. But that is what St. George looks like, at least to the north. Yeah, I'm starting to get more adventurous with some of my video techniques. I've been, I guess, practicing would be the best word for it. Shooting more complex stuff with chroma keys and editing and some other things like that. So there might be some interesting stuff coming out, depending on my level of laziness. Okay. Do you happen to know if Boost's GIL is deprecated, not maintained? That's a good question. I don't know. I would say that it is dead, but that's just my read of looking at what's out there for it right now. Have you tried the STB stuff? Because I believe that's actively maintained. Okay, so today's stream is an update, I guess specifically about the compiler, but also just generally what I've been up to. So I've been doing some client work, which has been keeping me busy, but also I have been practicing my writing daily, and I'm feeling much better with that after a month. I also, as I mentioned, have been doing more kind of stretching my bounds with video production a little bit, trying to get into some more complex configurations, chroma keying. Some of the things I tried to record last year ended up becoming very difficult to edit, and some of that, was just because I didn't know what I was doing. So I've been spending some time with that, and then of course also working on the compiler and thinking about, 20 other projects that I could be working on. But then forcing myself not to do that because I want to finish things. But I also spent a lot of time, so I've been refactoring the code generation in the compiler, but I also have been spending a lot of time kind of just thinking about the design and where it needs to go to get the bootstrap to where it has meta programming, everything is working. I have at least one native code target working. Although for the bootstrap compiler, I'm kind of seeing that as less of a requirement, but it's still, on the table. So, don't even know where to start. So, I guess, and I'm just thinking, okay, so Basecode, the language, such as it is right now, is a simple, imperative, statically typed language. It's not, there's nothing here that isn't anywhere else, really. I've made certain choices about the syntax that I like and some of the ways in which, things work. But, at that level, it's just another imperative programming language. So the big sell for me with Basecode has always been the metaprogramming that it would enable. And very early in January, I started playing with Terra, which is an interesting programming language. It's a statically typed, natively compiled programming language that is built on top of Lua. And I thought, this is pretty cool. Out of all the things I've played with, this is the closest to the kind of metaprogramming that I've been thinking about. But while Terra is pretty cool, and that is spelled like that, I think sometimes they refer to it as Terra Lua. It still has this bizarre property because of the way they built it, that the metaprogramming is not in the same language as the language, right? Now, Terra, the language, is very close to Lua in style, but it is different. And of course, Terra is typed, Lua is not. Lua is dynamic, right? Lua is typed, but it's very loose. You can coerce things very easily. And it's certainly not statically typed. Terra is very performant in terms of a compiler. I didn't really have any complaints in that department, but it did start me thinking about, okay, I hadn't really thought much about how metaprogramming was, how I was going to actually implement it. I knew what I wanted as the end result, but not exactly how I was going to get there. So I spent some time going through it, and I already knew some big picture things, right? So as an example, watching the videos from John and some of his team about J, it was pretty clear to me that the metaprogramming in J, now again, this is just based on what you can see in a video because it's not publicly available, so what I'm saying could be wrong, but my impression is that the way in which metaprogramming, there are two kinds of entry points to metaprogramming in J, it seems. One is that you can tell the compiler through the workspace model, hey, add this code, add this code, add this code, and it appears that the way in which that's done is through like templated here docs or strings or whatever, or saying add these files dynamically to the list of things that you're going to compile. And that makes sense, right? The other mechanism, it appears, is an event-based model where you give a J procedure to the actual compiler, and as things are happening in the compiler, right, as it parses a bit of the source and it generates AST, as it type infers something, as it, you know, does different things, you get a callback. And I don't know if anybody here ever had to write like a SAX parser for XML, but SAX was, in the Java world, was a callback based model, very similar to what it looks like J does. And the problem with that, it's great, like if you want to do, like I think one point John had a thing where he could define Go Bananas or something, and it would, the compiler would pop up this UI and it would play music and it would graph things. Event-based interfaces are great for stuff like that, because you're not really tracking a whole lot of state probably. You're just doing things that are going to show up on a UI or in some kind of report or whatever. Also, like an event-based hook could be easy to use if your goal is to say, look for any procedure that has a particular attribute on it or something. Although that gets tricky, right? Because again, in the event-based world, you're going to get an event for most likely the attribute, and you're going to get an event for the thing that comes next. So you have to kind of keep track of what's coming, and so that you know you've got a match. And of course, Terra doesn't work that way. I'll try to make my thoughts merge in the end, I promise. And I didn't really, like, the more I thought about that model, the more I thought, yeah, that's cumbersome, right? It's efficient, but extremely cumbersome. And efficient here, I mean, as technically the event-based approach is probably like the most optimal from the perspective of not doing extra work. So because you're getting into that pipeline at the earliest possible point. So when the compiler comes across something that you want to change, you're doing that right at that moment, versus waiting later and having to regenerate things and redo things. But I kind of set aside, you know, the worry about ultimate performance and efficiency, and thought about, okay, what's going to make this the most usable. The other thing I noticed is that I can't even remember now, I know there was a thing on Hacker News yesterday about Volt and the language V. Unfortunately, again, V is not completely released. There's only some samples out there, but that looks very interesting. Although they don't really talk about metaprogramming too much there. There was something else, it might have been, I don't know, I can't remember. There was something a while ago on Hacker News, and it was a language that supported metaprogramming. And again, a common theme that I see in the community with metaprogramming is everybody feels like it's a bomb, right? And that it's going to destroy your program and it's going to make it unreadable. And and when I compare the options that are available out there for it, I kind of agree, right? Like Lisp can very quickly become unreadable, even for the people who I think originally wrote, whatever they wrote. The language doesn't, in my opinion, doesn't really lend itself to making that stuff very clear long term. But I think the big issue is that I noticed that there's no easy way to debug metaprograms, right? It's like kind of just elided over. And you just have to you resort to like old-fashioned print debugging, or you just kind of have to cross your fingers and hope that that macro that you wrote, does what you think it ought to do. And of course, then what that does is that forces the developer to treat metaprogramming like this extremely delicate, dangerous, okay, I'm going to use it in this one little spot, and this thing is only like 4 lines long, and I can reason about, how it's working without having to have a debugger for it. So all these thoughts were going through my head, and then also like how I was seeing metaprogramming in the Basecode compiler, like how it was going to work. And so all that rambling leads to, here's the model I think I'm going to be implementing next. So the update at the end of February, I think will hopefully show some concrete progress in this direction. So here's what I'm going to do. I'm not going to initially concern myself overly with performance and optimization. The reason I say that is because I already have kind of instrumented the code in very primitive ways, and I've kind of convinced myself, bytecode generation is almost the least expensive thing that the compiler is doing right now. Parsing is the most expensive thing. And B, I can always optimize these things later. I can always try to get better performance out of it. And again, I'm not particularly concerned, right? Like, I don't think it's going to be a major issue. So what I plan on doing is this. I'm going to provide 3 mechanisms for metaprogramming. Mechanism number 1 is going to be very similar to like what I described with J. There will be an API where you can get the current compiler session, and you can manipulate it, and you can add modules to it, and you can add strings to it, and anything you add will just go through the normal parsing pipeline. And in that particular case, like adding new things, that's like the easiest case, but a very common one. There will be a hook for eventing, because I do think there are cases like logging tools or extensions to the compiler or things of that nature, where being able to hook into an event callback and have the compiler tell you, hey, I just parsed this, here's the AST structure, here's the state that I'm in or whatever. And I haven't quite settled on whether or not I'm going to allow changes in that part of the pathway, or if it's just going to be a read-only thing. I can argue with myself both ways in terms of whether it makes sense to allow that to be mutable or not. I don't think it's a problem per se to make it mutable. I just think that the last thing I'm going to mention is more powerful in general and probably doesn't. I think what's going to end up happening is that event-based thing, it would be very rare, right, that you'd ever really end up making any changes to the models as it's running, but who knows? So that would be the other. So that will be available, but I don't think it's going to be the predominant model for actually implementing the metaprogramming. Then the third model is the one I always kind of knew I was going to do, but it was fuzzy, it's pretty gray. And now that I'm much closer to it, I think I have a better way of describing what's going to happen. So this third model is what I'm going to call the DOM model, or the post-processing model. So just like the Basecode programs we have now, there's a run directive. Basecode compiles everything, and then the run directive is anything that's inside of a run directive is executed in the virtual machine. That's going to stay pretty much the same. And then I'm going to expose an API. It'll be a C API from the compiler to the Basecode environment that will allow you to access the DOM, right? The compiler model, which was always kind of the game plan. And I'm thinking through like what that query mechanism / API is going to look like. But I want to try to make it as easy as possible to say, hey, go find all the procedures that are tagged with this attribute and are in this namespace or whatever. But you'll be able to go out, query, and get back pointers to structures on the Basecode side that mirror the elements in the compiler DOM on the C++ side. And you'll be able to manipulate them. You'll be able to change values on them. You'll be able to add new elements, remove elements, shuffle elements around, whatever you want to do, okay? And so what's going to happen is the process is going to be compile code gen to the bytecode. Anything that's runnable will run. That can either do nothing, right? So if there's no meta program at all, or there's no run blocks, or those run blocks in no way modify the model, then that's it. Compilation's over, native code would be generated, and we're done. If you modify the model in any way, we're going to keep track of that, and then that's going to go back through the code generation cycle, right? We don't have to go all the way back to the parsing cycle, unless of course you get to that, your meta program adds a bunch of strings to compile. That's different. But let's just say you modify existing elements, or you insert some new DOM elements to do certain things. That is just going to bring us back to code generation. But here's the difference, or one big difference, and this is, I didn't have the clarity on what's going to happen is when you make changes to the DOM, it's going to be versioned. Now I'm going to say that very loosely because I'm not exactly sure what data structure I'm going to use to do this yet. But I have a couple ideas, and I'll get into those in a minute. And then what's going to happen is inside of session today, so if I bring up session here, and just as a recap, session is the container for a compilation session, right? So this is the entry point from the outside world into the Basecode compiler, and the session has everything on it. It has an access, or it has the FFI, it has the interpreter, it has the bytecode emitter, it has the AST evaluator, it has the element builder, right? So this is kind of where all the services live within the compiler. This is the thing that does the ultimate final type checking, and this is the driver, right? And if we were gonna talk about like parallel compilation, right? Session would be the boundary between one thread and another thread. And the way the compiler is written right now, with the exception, I think of the color, the console color generator, which I could fix. Everything else would be thread safe at that session boundary. But right now on the session, we have one set of ASTs. We have, one program. And again, the program element is the root element for everything that gets taken from source code and turned into the model. So we have one of everything. But that's not really sufficient. What we really need to do is have, as I mentioned, we need to have like a version chain of these. Because what I want to do is every time your Basecode program manipulates the model in any way and causes a change, I want that to version. I want to be able to see, okay, the first cycle, this was the original input, this is what was generated. So we have the source code, we have the bytecode, we have, what the DOM looked like. Then you made that meta program change some stuff. Okay, now here's what the DOM looks like after that, here's what the bytecode looks like, and so on and so forth. So every time you go through this cycle, we have a record of what was there before and what happened after the meta program touched it. So why would that be valuable? Well, that would be valuable because then the debugger that I have, I can enhance that debugger, and not only can I debug a program just the way you would debug something in any other debugger once it's compiled, I can now debug my meta program. And I can actually debug it over time, which is the way you would want to debug a meta program. You would want to be able to say, okay, let's walk through each cycle of this and see what it's doing to the code. And I think that's going to be a critical feature. because then, in my opinion, what that does is that lifts the burden on some level, maybe not completely, but it lifts the burden of thinking about more complex metaprogramming, right? Because now you don't need to fear it quite so much. Now, again, I'm not saying it's not another layer of complexity. It is. And it's going to be a unique layer of thinking that people are going to have to take on board. But comparing it to other environments that have macros and metaprogramming, I think this is an edge because they don't have it, and they're not really contemplating it, which to me then is always going to be a limiting factor for how much uptake you would have for metaprogramming. So Gmon asks, is the versioning for the tags or some module system? So the versioning is for the DOM. And keep in mind when I talk about versioning here, I'm talking about versions of the program model over time during a compilation. So if you run the compiler and it generates 30 versions of your program model, but you don't debug it, right? That data's gone, right? Like it's there while the compiler is running. And if you are in the debugger while the compiler is running, then obviously you can inspect and look at and access all those parts. But once compilation is complete, right, that data is gone. Now, I say that, obviously I'm probably going to extend like the listing files, and I'm probably going to have options where you can say to the compiler, hey, output metadata about how the model's changing during each cycle. But that's going to be like a text file that you look at, and it can help you and give you some insight. But you know, the real deal would be if you needed to step through your metaprogram and see what's happening at every stage. That would be the way you do that through the debugger. And of course, obviously, if the metaprogram is doing what you want, then you're just going to run the compiler and it's just going to do its thing, and you know, you get your program at the other end and you're done. For interdependent lookup stages, no, think about it like this. You have a program, okay? Let's take a really simple case. Right? This isn't very simple. I want something even simpler. Come on. Okay. Let's say we have a variable. Let's say we have a binary operator, and that's it. Okay? Super, super simple. All right, let's say that, let's pretend for a moment, because I don't know what the API is quite yet, that there's a run directive here, okay? And inside of here, we're going to manipulate the code DOM for this. And we're actually going to do it many times. So there's going to be code here that's going to run each time, and it's going to look for an identifier called A, and it's going to look to see if the value is 50. If the value isn't 50, it's going to change the literal. It's going to increment the literal by 10 every time. So what's going to happen is this code is going to run 5 times before the condition fails and we don't change the model. So very first time in the original source file, A is equal to 10. But then the metacode's going to run and it's going to make A 20. That's a change in the model. The compiler is going to detect that, It's going to regenerate the program again. That's version number 2. Version number 1 is the one that came from the file system. Version 2 is after we've incremented it to 20. Then it's going to do another one, and another one, and finally another one. And then the condition's going to fail. We aren't going to modify the document anymore. We aren't going to modify the code DOM in memory. And then the compiler's going to say, oh, okay, well then nothing's changed, so go to the final code emit for native, done. So these versions I'm talking about are tracking what's changing in the code DOM from cycle to cycle to cycle. And those changes in the code DOM also, I want to be able to link those to what bytecode / source code would be different. And that highlights an interesting thing that I need to work on here soon, which this shouldn't be very difficult, but I need to be able to take the code DOM and turn it back into source code so that at least within the debugger, I can show you, oh, okay, in version 3, A is assigned to 30, right? Because that's what we changed in the model. Now, there might be, I got to think about, and this is one of the next things I want to talk about, but I got to think about some of the fidelity in the code DOM a little bit, because if I'm going to regenerate source from the model, I would like it to be as close to what would have been handwritten as possible. So, and right now the code DOM is missing maybe a couple small bits of information that would make that reasonable. But I don't think it's insurmountable. So hopefully that kind of gives you an idea. And of course, again, when you run the compiler, right now, the debugger is built into it, whether it's this text-based debugger I have, which would be, sufficient, right? It'll work. Eventually, if I have an external debugger that would plug into something like the IntelliJ platform or whatever, then it would still, fundamentally be doing the same thing. And you would literally be able to step through the code here, and every time the meta program makes changes, the compiler is going to rerun. The compiler is going to bring you back, the debugger is going to bring you back to the beginning again, right? And you're just going to keep cycling through your meta program until it finishes. So really, the debugger will have 2 different states. You'll be debugging the compilation, or you'll be debugging the actual result program. And the debugging the result program, that's very similar to what we have today, right? So at that point, you're back in more or less normal land, and it just does what it does. Yeah, that's kind of what I meant, but worded poorly. The compiler needs to know the type for A to resolve B in its multiply operator. Well, yes, although it already does all that, right? That part's not really the issue. The issue is, I'll see if I can, here, let's do this. A assignment would be compiler find element with, or find identifier A. Okay? Now again, I haven't actually written this API yet, so I'm spitballing here. This A assignment is going to be a pointer to a structure that has, fields in it that let you look at the assignment. Okay? So, we'd probably do something like then a assignment initializer. Well, yeah, see, this is where I haven't really thought about the API yet, but let's say we do right-hand side is equal to compiler make integer literal a assignment right-hand side plus 10, okay? And maybe this, we can even just do this, right? Because if this is already a integer literal, we can maybe just add 10 to it because, again, we can change operator behavior here. So, and that's it, okay? So all the meta program does, but there was one other part. If a assignment right-hand side is less than 50. Okay. That's really what we want. So what's the meta program going to do? So again, this messes with your head a little bit. This is the program. Okay, all it does is assign 10 to A and multiply A by 5 and put that in B. Okay, doesn't do anything else. But we have meta code. So this is code that would never appear in the final program. This gets stripped at the end. Okay. But up until then, right, if there's valid code that can run here, it's going to run. So what's going to happen is the compiler is going to compile everything to bytecode. Then it's going to run the bytecode that was generated for this block. The very first thing that does is ask the compiler, hey, bring me back an identifier called A. And we get back a pointer to a structure that has left-hand side, right-hand side, some other stuff on it, whatever that's going to look like, right? But approximately we know it's going to have a right-hand side on it. And again, through operator overloading magic, we're going to probably be able to deal with comparing, like right-hand side probably would be a pointer to a, you know, numeric literal something or other. But you'll be able to compare it to a integer constant if you want. So that what we're basically saying here is, hey, if this is less than 50, then add 10 to it. That's it. So, and actually let's use the shortcut syntax. Okay. And now what's happening at that point? Well, at this point, we just changed the code down. So behind the scenes, when this is mutated, the compiler is going to see that, and it's going to track, right, the original version of this, and it's going to track that, hey, during this compilation step, cycle, version, whatever you want to call it, this element's field changed from this to this. Okay. We fall at the end of this block, something happened here, right? So we have a dirty flag essentially in the model, and the session says, okay, did anything happen to the model? Yes, something did. Okay, go back, regenerate the program again, regenerate the bytecode, right? So we're going to tell the interpreter, clear the heap, regenerate. Okay, that's going to happen. Now, but this time, we're going to end up with a version of the program where this is 20, not 10. This will fall into this block again, because that's what happens. And this is still less than 50. We'll still increment it. That process will repeat. And then we get version in memory, right? You get this all these different, slightly different versions of the program. And then when we get to that case where it's 50, this won't happen. Because it doesn't change anything, the rule in the compiler will be, well, nothing changed in the model. Because nothing changed, okay, don't. No, because the stack is reset every time, right? So the execution state from version to version is distinct. So it's not continuous, because they are different programs at that point. But what I want to do is I want to be able to show you as the developer, here's the sequence that happened, right? So in the debugger, there's going to be another layer that you're going to be able to step through or walk through, where you're going to be able to say, okay, I want to go back in time and see what it looked like the third time through or the second time through. And then you can walk forward from that point, or you can go back to the beginning or to the end, whatever you want to do. But yes, both the C++ stack and the bytecode stack will be reset, right, every time through the loop, because you're starting over, essentially. The continuity, I guess, is just being able to see what's happening to the model from version to version. Because again, the more complex your metaprogram becomes, the more it's doing, you're going to maybe at some point want to be able to see what that is. And yeah, so that's the idea. So in order to do this, step one, which is what I've been working on up until now, and I think I'm getting pretty close to wrapping it up, is I introduced a new class, bytecode emitter. So this is in the compiler. It's kind of funny because I had this class for a while and then I got rid of it. Now I've brought it back. And I've consolidated all of the bytecode generation into this class. It's just a series of functions, and everything now is just kind of like, for example, emit element is kind of the core here. It's just a huge switch. And if you remember, this used to be polymorphic. This used to be on element, and then there used to be an on emit overload on the element that you could provide that would do the emit for that particular element. But, and this is where, you know, all this thinking kind of started me down this path. I realized I needed to start to pull behavior out of the elements as much as I could, because what I'm going to do is I'm going to introduce, and it's close, but not quite. I'm going to refactor the element system and the AST stuff slightly. I'm going to introduce a true ECS into the compiler. I would say right now I have a pseudo ECS. That's entity component system. And really briefly, and you can read about it, entity component system is, an entity is just an ID. Components are buckets of data. Components can have behavior, I guess, but really the third part of that ECS is systems. And systems are just functions that operate over a collection of entities. And typically they operate over a collection of entities that have particular components on them. So the way I'm now kind of seeing this is kind of beautiful. once I get there. What's going to happen is I'm going to create an entity very early on in the process. The AST will be a component on that entity. The elements will be components on the entity, and then as elements are versioned, most ECSs have like a generation number or version number. So as an example, let's say that entities are like statements. I mean, that would be probably a reasonable boundary condition in the language for an entity. So every single statement is an entity. And then within that entity, you have the AST components that define it. So that, as an example, if we go back to our super simple, this is a statement. So there'd be an entity. Let's just say that's entity number 1. There'd be some AST in here, right? So there'd be a statement AST node. That statement AST node would have the left-hand side as a symbol. It would have a binary operator as an assignment. It would have the right-hand side as an integer literal, right? So you imagine now we have this entity. It's going to have this AST statement in it. Then, just like we're doing now, that's going to go through the AST evaluator. We're going to turn that into elements. You know, that becomes a statement element, and then that statement element has an assignment which has a left-hand side and a right-hand side, and but that element is, so the difference is that those are components now on that entity, and if I create another statement element on the entity, I can version it. So there's 2 instances of that same statement. The first one in time has A equal to 10. The second one has A equal to 20. The third has A equal to 30, and so on and so forth. Right now, the model, I don't have that, I don't have the entity part, and I don't have the container. So again, typically like your ECS is the container, right, that's tracking the relationship between the entity and its components and the versions of those components. Or the version of the entities, whichever way you want to look at it. So I need to refactor it to introduce that new piece into the picture, so that every time I run through this compile, modify cycle, I can tack things on to these elements and easily get back to them for visualization and debugging purposes. And then the other thing I want to do is, of course the bytecode is going to be separate from the model, but I do want to have a component maybe, and this is why I was saying there might be a few small things that I'm going to have to track that are different than what I have now, that will allow me to link, okay, for this particular version of this, that actually references this address range or whatever, these instructions, so that I can easily in the debugger, right, jump around and show you, hey, here's where things have been modified, right, from one version to another. So that's the grand plan. And then while I was thinking about all that stuff, I did some, like I say, very primitive instrumentation. I'm going to take this out because it's slow as shit. That's the that generates the dot file for the code dump. It's a lot of file I/O. So I added some code to the compiler so that I could kind of track how much time, these are all in microseconds, each step or each phase, hey Cyanox, is taking. Now, some of these, the numbers are not, they're not as accurate as they could be. The way though that you can read this is the model generation part that includes parsing the text, turning it into a code DOM, took 33 milliseconds for this particular file. And then these values in blue, these are part of that. The problem is they don't exactly subdivide the way that they should, because I was in a hurry, but they're close. It gives you a general idea, right, of what it's costing to do some of this stuff. As an example, parsing the intrinsics file and compiling that into the model, right? So the read the text and turn it into an AST took 6 milliseconds. The conversion from the AST to the code DOM took 4 milliseconds. So 10 milliseconds total for those two steps. So again, at this very high level breakdown, bytecode generation is taking 14 milliseconds, but writing out the listing file takes 24. So, some of these things where they're file system bound or whatever, they're slow as shit. But relatively, right? It's all relative. Hey, gamer. But executing the bytecode actually is only taking 103 microseconds. So yeah, bytecode running, the bytecode runtime is very fast. It's not, again, it's not as fast as native, but compared to everything else the compiler is doing, it's typically a very small portion. But where I was going with this is, if I were going to multi-thread, or actually have like a more advanced job system, I think the big target to go for would be the parsing / code DOM portion of it. And the good news there is that really the compiler is kind of designed to be okay with that. Meaning that modules are all independent anyway, and identifiers that can't be resolved at parse time are just resolved later, right? But the cost of consuming the file, parsing, lexing it, parsing it, converting it, that could be threaded, right? So like on this computer where I have 24 cores, I could, like, each one of these could have been given their own core, and then at that point, the way that I think the performance would end up, working out, and this is where these numbers aren't quite right. What you have to do is you'd have to subtract out, right? These aren't subdividing quite right. Well, you got to keep in mind that with Basecode, my assumption is that because of the meta programming, you would be using Basecode for your builds as well, not a third-party system. So that's kind of why I'm even thinking in that direction. Because the way I would ultimately see this working is you're going to have a meta program that's your builder, and that builder is going to kick off a bunch of stuff that's going to generate the rest of your final output. But this guy is not taking 32 milliseconds. you'd have to subtract out some of these. Well, let's say that this is like 13 or 10 or something, and this is the same. This is like 13 or 10. So then on the threading side of it, if we split all these up into their own thread, the long pole in the tent then would, generally speaking, be your timing on these. So, you know, if this one's 13 milliseconds, then roughly speaking, the total time, I think, to do the model part would then roughly be 13 milliseconds. Now, there'd be a new non-threaded step at the end, though, because we'd have all these separate modules where we're keeping track of where they originally were. We'd have to like quickly zip them back together. However, I don't think that that's probably going to be a pretty tiny cost, but we would still have to pay that cost at the end. But I do think ultimately you'd end up with a benefit, right? Doing that. So introducing a really thin, simple job system into the compiler, and again, specifically for this part of it, right? So if you ended up having 200 modules, you had a machine that had 4 cores, we could chunk through those 4 at a time, and then we'd have this final, you know, merge is not really the right word, resolve, tidy up phase at the end of that. So I'm also considering that too. And like I say, I already sort of have been refactoring things in that direction, so it shouldn't be too bad. But with all that said, let's talk about changes I've made to the assembler and code generation. So lots of bug fixes, lots of little things. I was able to kill a bunch of stuff that was no longer being used. Hey, Dark Knight Studio. Let's see. So one thing that is new is that the assembler, I'm actually treating instruction blocks more like true basic blocks. Not quite as fine-grained yet, but closer. And the primary reason why those are actually, I kind of improved those and made them more of a real thing, where the assembler actually recognizes a directive now, is because locals within a block, they live for the duration of that block, right? So the assembler allocates registers, and then at the end of that block, they're dead. So every time we get to a new block, we have a fresh set of locals. Most of the type stuff stayed the same. I think there was one bug where I fixed, I think one type wasn't being recognized properly. Some string constants, there were some bugs here where I was grabbing like, here, we can just look at it. Like I was grabbing this, I was grabbing this. Technically it is a string literal, but it's not something we want to put in memory. It doesn't need to go there. So I kind of fine-tuned what text is being included in the heap for string literals. So it's much better now. It's not including stuff like this. And then some of the variables so module level variables in Basecode are, I guess when you get down to the assembly level, they're globals. right? Now they don't clash with each other because they're identified uniquely with an ID. So every single module in your program could have a variable called text, and they won't stomp on each other. They're independent. And they could be different types and all that good stuff. Excuse me. But at the end of the day, they all dump into either BSS or data, right, in the image for native code. Again, the interpreter doesn't care so much about this, but the interpreter is very much designed with the idea of native code generation, right? So I'm mirroring a lot of the constructs that would ultimately be needed to get to a native code output without gobs of work, right? That's the goal. So the bytecode emitter does a lot of upfront work to say, okay, this would go in BSS, this would go in data, and some things that should have been in BSS weren't, and some things that should have been in data were in, it was a mess. So I fixed that. So now things that should be in BSS are, and things that should be in the data section are in the data section. So that's fixed. And there were a couple things that were ending up in memory like constants that shouldn't have been. So I fixed all those bugs. So the new stuff, right? So this is a procedure, right? So I have a couple new directives, and some of these started life in the inline assembler, but I realized, hey, why don't these just move right into the assembler proper? So some of you may remember that I had these, it was stupid. I had these goofy structures in the compiler that were tracking, like, here's where frame offsets are at. But it was all like, yeah, it was just stupid. So anyway, instead of having state in the compiler, which isn't strictly necessary, I just take that data that I compute once up front, and I just emit directives now. So I tell the assembler, hey, frame offsets for locals start at -8. Frame offsets for parameters start at 16. Then I pushed the iLocal, fLocal construct down into the actual assembler proper. So iLocal is telling the assembler for the name string, there's no offset. This is the offset group it belongs to. I need an integer register, okay? Same thing with lit, same thing with length. These are the parameters from the actual Basecode source. So if we go to, I think it's in types, assign string, so we have stir, lit, len, right? So these match now, and these are all parameters. They belong to the parameter offset group. So the way you read this is the starting point. So in other words, whatever the frame is, I can define the frame once up front. Those are kind of constants. And then offsets are always starting from 0. So you don't have this weird thing where you're not really sure why this offset was 24 or whatever. You can logically say, okay, it's 0 plus 16, plus 16, 16 plus 16. So we encode all that information about what the frame looks like in these directives. And then, and this is one of the last things I'm working on right now, we need temp registers. We need temp variables, places to put stuff, because this is a register machine. It's also a load store architecture. So very often, right, we have a pointer to something, we have to load it from memory or load it from wherever and put it back. But we have to put things in temporary registers to use those for other things. So in this case, I'm allocating 5 integer temps. There's no offset on these because they're not in the stack. And then what I'm doing is, again, if we go back like a month, the compiler would generate code here where it would be loading and storing from the frame pointer constantly. And it was just messy, right? It's not so much, I think, that performance really is any different. It's just that you had offsets repeated a lot more frequently. And then also your stack offset from the beginning of whatever's on the stack would get mixed with your struct offsets. So then you would have to kind of work them both backward, right, to know which was which. And I just thought, okay, I want to make this clear, right? So these I0, I1, I2, these are being fed to us by the assembler from the local. So actually what happens, and I'll show you the code here, this move instruction is not encoding I0 when we create it. It's encoding this name, stir, right? And then at the very end, the assembler is allocating those registers and fixing all that stuff up for us. So what happens is we set all these registers for our local variables to their address in the stack. So we do that once. So then as an example here, we set I2 to point to the length variable on the stack. Then we actually load the length from the stack, right? But now we don't have to do that offsetting. We can just load from that one register. Now, obviously you're going to say, okay, that's great, but what if you run on a register? Well, first, that's a given, right? Because on most physical architectures, there aren't that many registers, especially like Intel. Although Intel isn't as bad today as it used to be. So at some point this will spill, and I need to add the code to do that. But what then would eventually happen, right, is my goal here would be to hit the hot ones, right? So if you're referring to one particular parameter a lot or whatever, those addresses would get cached into a register. Everything else would then just do what it did before. It would just load directly from the frame pointer or stored directly to the frame pointer with an offset. But in the bytecode, we have a ton of registers. So most of these aren't going to probably spill. It will when we get into the native side of things. It probably won't spill as frequently in the bytecode world. So you can see here, we load the length. Here you can see that we dereference, right, this pointer here. So then the other thing that came about from this change, right, was the way that the register allocation used to work was very stupid. It was very brain dead. I basically would just I had a single register allocator, and as we were generating bytecode from the top down, registers would get pulled from the allocator and put back, and it would mostly balance out. But if you had a long string of code generation where you were going from procedure to procedure to procedure, the registers would essentially just kind of slowly bump up, and they wouldn't overlap. But now the code generator is reusing registers aggressively, which is what I wanted. I wanted it to be a much more efficient allocation of registers, but that introduced a new defect. and that was that from procedure calls, I was not saving register state. And then my first cut of that, like about mid-January, I was pushing and popping just directly each register, but we have 7 registers in use here, and that was ugly as hell. Also, and now again, once we get to native code, this doesn't really matter, but for the interpreter, 2 things. I added a push M and a pop M. So it's push multiple, pop multiple. And you can specify up to 4 ranges of integer and or float registers, right? And ranges are, low to high or high to low, depending on which order you want to do it. And for the interpreter, this is an advantage because it's going to be faster for the interpreter to do one thing than it is for it to do 15 things, right? But it also cleans up the disassembly. So it's easier to read push M, okay, 0 to 2, skip 3, 4 to 7, then it does its stuff. 3 is the return value, and then when we, restore register state, it's 7 to 4, skip 3, 2 to 0. So it just makes things easier to read. But now procedure calls are properly saving and restoring register state from call to call, and I'm gonna probably have to revisit the return value. Sometimes this can be popped directly off, sometimes I'm gonna have to do something slightly different. I might have to address it essentially, because if it's a pointer to something, which I need to fix that part of the code generation anyway. There unfortunately are some bugs here, and they revolve around how I'm allocating. So yeah, how I'm doing temps, and I had tried this really aggressive fixed allocation approach with temps, which works like in 90% of the cases, but there are a couple cases where you have instructions like fill or copy that take 3 arguments or 4 arguments, and then you have dereferences in between the left and the right side, and there are some issues there, and that's really kind of what I'm debugging and reworking now. The other thing, so let's look at this example. This is the next power of 2 procedure. So if we go to math and we go to next, oops, wrong window. So next power 2 is just doing some binary trickery, right? To get, if we put a value of 12 in here, right, this will get us to 16. So we subtract 1, and then we OR the right shifted by a certain amount to itself, and then finally we bump it up by that 1 again, and we're to the next power 2. That's fine, that all works. The code that gets generated for it is fine mostly, but here's an example of where this is what I'm kind of trying to fix right now. Is you can see we're loading the same thing twice. Why are we loading the same thing twice? Well, because the compiler is pretty stupid at the moment, right? The left-hand side and the right-hand side are the same, but this could be optimized, and ultimately, but you'll notice it's reusing the same registers over and over again, which is what I wanted. So it's compared to the code generation I had before, This is much more efficient, right? It's reusing registers the way I would want it to, except I've kind of lost a little bit of state that I used to have. Yeah, exactly. Cyanox knows where it's going. So what I think I'm going to evolve to here, and I've been thinking about this really a lot today, is I think I'm going to end up with a structure in the compiler internally that maps temps to the live variable that they're dealing with. And what that will let me do is get rid of some of this duplicate shit that I don't need. The other thing too is like restoring, like here we're storing, because technically that's what's happening here, but we don't have to do it until the very end, right? Because we're just mutating the same thing, we can actually have one load, a bunch, one load, one sub, a bunch of shift rights ors, and then a store, or an add and a store, and then we're done, right? So this is a kind of a really good test case for, again, trying to fix the allocation of these temps. In this function, it breaks because it ends up reusing a slot that it shouldn't be, and we end up with code that blows up. I know exactly, like I say, I know exactly what's causing the problem. It's just I need to restructure this so it's smarter than what I've got. And I got to strike a balance between reusing, like I want to regressively reuse registers as much as I can, right? Like this is perfect. There's no reason why this doesn't work, but it's just, in this case, it's right, but in a couple other cases where there's more register activity at the instruction level, it's kind of messing up. Inline assembly still works. The locals that you define your inline assembly just end up being within that block of the inline assembly itself. But the nice thing is that the actual inline assembly is a bit cleaner than it used to be. So if we look at assert, level has already been, the compiler has already created a frame offset. It's already created a iLocal for the parameter and the return value. It does that for us. So as where in previous versions of this, the inline assembly was having to deal with the offsets and all that, that's already pre-done for us. So that's nice. What was it times? No. Yeah. So, but yeah, everything else works the same. The module operator and the offset operator work. You can still use those. So that's all good stuff. The only thing that, so technically, like in this one, I have a return value. The assembler can, like there's already a local cult red val, right? But I haven't really played with that yet. I need to get back to that. I'm gonna try to, like, the return stuff in procedures needs like a day or two of loving. So yeah, I'm gonna try to get back to that once I get some of these other bugs fixed. Okay, so yeah, we talked about frames. And oh, the initializers, I discovered a really nasty bug in the way initializers were working. So I fixed that. So now things are being initialized the way they should be. I do need to add some code to kind of try to, it'll be a heuristic. Because I don't want to have something that's super expensive, but I want to have something that kind of generally tells me, hey, starting from this block down, there isn't going to be any code emitted. Because we have all these blocks that are empty, they don't do anything. And they're just, again, this doesn't hurt the assembler, nothing special is happening here, it's just noise. So then we get down here to our compiler variables module block and, generate our locals for the module variables, and those get addressed. And again, whenever we call a native Basecode procedure, when we call a foreign function, we don't save register state, because foreign functions don't modify our registers in the interpreter. But for our stuff, we have to save them. So here's an example of calling a foreign function. We just push parameters onto the stack. We don't worry about saving register state. And code generation wise, other than I fixed a couple other small bugs, I mean, it's basically what it should be, except the temp issue. And I also made some final decisions in terms of how implicit blocks work. So, as an example, this, if we ignore the run, right, this is code. That's a green screen. I'm not outside. It just looks pretty. I'll probably change it, every month, find something different. But yeah, so like as an example, this calls assign string, right, in the module. And I kept going back and forth, like, okay, are these implicit blocks, are they scopes? Do they actually create, frames on the stack? Or, what are they? And I came to the following conclusion, which I might change, but for now, anything that is at module level deals with, it doesn't have a frame by default. You can, of course, access module level variables. You can call procedures. You can set stuff up, whatever. And obviously, if you create a scope within a module block, right, this would have its own frame. But this stuff by default does not have a stack frame. This doesn't have a stack frame, right? This is all at the module level. And if we take a look at like math, right, this is in a namespace. And so again, for a while I was kind of like struggling, is this actually a stack frame or not? The answer is no. This is anything within a namespace is the equivalent of the module that it lives within, in terms of like, if I define a variable here, right, this variable from a language perspective is accessed within this namespace, but this is a module level variable. If I make one that's mutable, right, this is a module level variable. Now, linguistically, you have to access it through the namespace that it lives in. But at the end of the day, this is on the heap. This is a static, right? And any code that you define either at block scope or within namespaces runs as if it were in block scope, or within module scope, sorry. And so that means it's going to run when that module is processed, right? In sequence, that code's going to be emitted. It's going to run once, and that's it, right? Which is fine, because again, my conception for why I would even want code here to run would be to set something up, to initialize the module, to prepare tables or whatever. And of course, it goes without saying that you could, have procedures, and then, at the end of this or whatever, you could just call internal procedures or whatever, and those would run, and you could accomplish the same goals that way. So, and so that was something I was kind of vacillating on in terms of what the scoping rules were going to be there, and I think I've settled on what makes the most sense. And excuse me. Oh, and I didn't, maybe I've mentioned this in the past, but like if we take an example of the current core module, I have one special case right now, which is the intrinsics module, that has to be imported first. And technically it doesn't even have to be first, it's just that if you want to use any intrinsic functions, you need to do this early because it's inside of this module that we define the intrinsic prototypes for, or the intrinsic procedure types that the compiler then uses to map to the procedures it has for those. After that, right, you can do things in any order you want. But we're pulling all these module references in, and then we import the public namespace. So what this is doing, right, is this is taking any symbols that are defined in the public namespace from that module reference and pulling those into the root namespace of this module, which is core. So if we then look at how I'm using it, I'm referencing the core module, which loads this file in my program as core. So then every other symbol is just being pulled into that namespace. And of course, I could pull it into another namespace if I wanted, right? But I'm just pulling them all into that one flat namespace. And the way I get to that is through that module name. So that's working the way I would want it to. But I wanted to revisit briefly. So again, Basecode doesn't have any access control. I'm using the name public here just because it's easy to remember. But public here has there's no built-in connotation. This could be called foobar. It doesn't matter. However, using these namespaces would be a way for a module creator, for a library creator to I'm going to say soft hide implementation details. I say soft because if I have something like Bing Bang, right, in here, that's defined, okay, I'm not going to be able to get to Bing Bang, right? I should not. This should generate so if I try to do core Bing Bang, right, the compiler should tell me that it can't get to that because I'm not importing that symbol into the core modules, core modules namespace, right? It doesn't know what that is, and that's exactly what it should be. So you can softly hide things. Now I say that because, again, if you know it's there, then you can get to it, right? The language doesn't prevent you from getting to it. It's just that, so as an example, that was in math, right? So I should be able to do that. Because Bing Bang is in the modules namespace for, yeah. So again, if you know where it's at, you can get to it. But you can kind of, you know, again, like I say, in a very sort of intention only way, you can kind of subdivide things with namespaces so they're private or privater. So I fixed a bunch of bugs. The reason I talk about that is I fixed a bunch of bugs around that. The module reference was screwing up scopes and things were ending up in the wrong spot. So I fixed a lot of that, and that's all working the way that it should now. So that's happy. There are a couple of other minor things around namespaces that they're just, at worst, they're annoyances. So once I get some of this other stuff done, I'll probably come back and spend some time on those. So yeah, I think that pretty much covers where things are at and where I want to go. And yeah, so, oh, there was one other thing I wanted to kind of talk out loud about here. So, type promotion, God, such a horrible concept. So currently, the compiler is ultra strict and it does not type promote. And I'm really, yeah, there you go, Cyanox, no type promotion. I'm with you, man, I really am. But I don't know, I want to talk through it just to convince myself that it's okay. I mean, type promotion is evil, right? I mean, I gotta throw that out there. It causes pain and anguish, and for every situation, yeah, I know. For every situation where you would say, that's it, I'm never gonna do type promotion again, you could say, yeah, no, you just have to cast it. But yeah, here's the issue, and I think I'm in total agreement with Cyanox's position here. I share the same viewpoint. I think the theoretical niceties of type promoting are theoretical, and in practice, it's just dangerous because you don't know what the compiler just did. I mean, that's ultimately what it comes down to. And yeah, it's just dangerous. So what I'm gonna do, the compiler does not currently issue an error for type promotion scenarios. I'm gonna do that. So what would happen then, this is a U32 here, and Alec is expecting a U64. So what should be happening here is the compiler will see that this would require type promotion, and it'll blow up and issue a specific error saying, did you mean to cast, you need to cast this, basically. So, yeah, I think I've convinced myself that that's what needs to happen. So I need to fix that bug so that we get the type promotion errors properly. And, you know, at the end of the day, the casts are not, it's not hard to do. It's just, you know, yep. Well, again, type promotion is, it's happening behind your back. And I think, you know, the extra characters that you have to type to be explicit and say, okay, this is a 32-bit number, and I recognize I'm casting it to a 64-bit number, and that's going to cause it to zero extend, right? I'm okay with that, right? Or if it's signed, it's going to cause it to sign extend. And again, this is where I think, like, the C compiler, the C folks ended up going down the road of allowing, you know, hidden type promotion. But yeah, it's just, more often than not, my experience has been that it's those hidden type promotions that cause all sorts of weird shit to happen. Especially the lower level you get, right? So yeah, anyway, it's just one of those subtle bugs that, and what happens when you type promote assigned, yeah. So again, I'm making you pay, you know, 8 character price plus some parentheses, which, you know, honestly, like in an IDE, you could select this and say surround with a cast or something. It's not, you know, it's not really so much of an issue, I don't think. And like here, okay, I'm casting the same thing twice. You know, I could put that in a local. So yeah. Anyway, yeah, I just wanted to talk through that one, but I think I've convinced myself that that's the right thing to have happen. I don't know, is there anything else? Yeah, I mean, like if everything is always a U64, then yeah, I could probably see where it's not an issue. But yeah, the problem is there's enough difference, and you're not always targeting that type. Like again, you can stuff a double right into an integer. I do that, you know, in the compiler and in the interpreter, but I'm very careful about it. I mean, I use type punning where it makes sense, because sometimes how else can you do stuff? But yeah, I recently was bitten different code base with a 16-bit value that was being type promoted, and it was just, it brought me back to that code, and I thought, you know, I gotta force it. And then, you know, it's like anything, I'm gonna make it super strict to start, and if after doing that for a while it really annoys the shit out of me, then I'll revisit it. But yeah, for now, I mean, and Rust is actually pretty strict too. I think Rust has a couple cases that it will promote, but overall, Rust requires pretty consistent casting as well. So I think it's a pretty good position to take. So yeah, I'm going to fix that. And so for the month of February, I'm going to finish off the code emit stuff, which, like I say, I'm really just working on the temp allocation, getting that kind of fine-tuned, and I need to fix some bugs and some other things in the code emit, but by and large, right, like that's pretty much good to go. Then after that is wrapped up, I'm going to then start the refactoring on the session and the models, introducing an ECS into the picture. I think I'm just going to use an existing library for the ECS. There's one called ENTT. It's pretty good. I've used it on a couple other small projects recently. I'm happy with it. So I probably will just use that in lieu of rolling my own, because why spend the time? I mean, I'll have enough time wrapped up in kind of refactoring what I have. I've already pulled out a ton of behavior from the elements as it is. I need to kind of make another pass at some of that and move some of that behavior into what will eventually become some systems that will deal with those things. So really the element model is gonna hopefully kind of shrink a little bit. I mean, we'll still end up with the same kinds of things, but they won't be quite as implementation heavy. Most of that will just live in functions. The other thing that's going to be really nice about this is I can also kind of get a little bit more control over memory management, because when I profile this code, I mean, ultimately where most profilers say time is being spent is in the memory management code. So if I can, with using something like the ECS, I can do more of like an arena type allocator, or maybe slab allocators even for some of the really simple stuff. So yeah, I might be able to reduce some of the memory overhead there. And yeah, that's pretty much it. And by the time I get through this next round of refactorings on this session, introducing the job system, some threads, introducing the ECS, restructuring how the AST nodes and the element nodes are being kind of tracked, and then get that meta programming cycle going. I'm probably going to end up spending a good chunk of the month defining the API between the C++ compiler and the Basecode program. And I'm going to have to, I'm still thinking about, because for FFI, I mean, it's possible to map to C++ name mangled functions, but it's annoying as hell. So probably, most definitely, the API is going to be very C-like between the compiler and the Basecode environment for all the meta stuff. But I need to somehow be able to know which session you're running under. So I have a couple of ideas of how I would do that. I probably am going to use one of the trap vectors or the initialization vectors in the terp to just store a pointer to the session, and but I haven't quite decided exactly how I'm going to do that. But yeah, I'm probably gonna end up spending a good chunk of the month working on that API and getting that up and running, and then making the changes to the compilation pipeline such that after you make changes to the model, those are detected and we run through the process, over and over again. So yeah, anyway, that was pretty much what I wanted to cover today. Just, kind of a light status update, and yeah, so I don't know, anybody have any questions, thoughts, rumors? I'm at home. Yeah, I'm at home. Back in Utah. So I'll probably be doing a little bit of traveling on and off over the next 6 months or so, but it'll just be here in the States. What's your stream schedule going to look like going forward? So here's my plan. I probably will be doing a couple streams here and there over the next 4 weeks. I don't want to commit to a specific schedule because I'm not sure exactly which days I can do it. I have a bit more variability in my schedule at the moment than I had last year, so it's difficult to nail down specific times. But I do think in February I probably will be doing some ad hoc streaming, not at the level I was doing it last year, but more than I was in January. But I'm also really looking at, I've been kind of just doing some test shoots and test editing, and I've been looking at stuff I can do on YouTube. I would like to finish my C-Kong series. I've kind of let that languish. I'd like to finish that up. And I have other ideas of other things like that I could do on YouTube. So I'm probably going to be putting some more time into that here in February. Also, I'm working on getting my nybbles.io website redesigned and getting some writing and material kind of in the hopper, so to speak, so that I have plenty of stuff to just kind of keep rolling out on the website. So not exactly sure when that's going to be ready to go, but it's on my top 5 list, so I'm working on it behind the scenes quite a bit and trying to get it to a point where I can get that going. And again, I'm trying to get enough of a pad, a buffer, such that I have a lot of good content that's coming out, and I don't have to stress every day about writing. I still have to write every day, but I'm writing for stuff that's going to go out months down the road, sort of a deal, instead of I'm writing for something that has to go out today, which would probably just drive me insane. So that's in the works, and it is a priority of mine to try to get that out as soon as possible. So right now, yeah, that's kind of my workload and my plans. I want to get Basecode, the Bootstrap compiler. I want to get to this, what I talked about today. I want to get that done because I have several projects, one or two of which I might then go back to streaming much more frequently, because I would like to we're gonna obviously have to rewrite the compiler. I'm gonna self-host it. I probably will not stream that because, quite honestly, I think a lot of that's going to be boring. It's just going to be retreading stuff that I've already done. Not to say that I won't do touch points like this. I think doing like little status updates would be good, but I intend to use the Bootstrap compiler to do a couple other projects. And one thing I would really like to do is work on a game, and I got a couple of ideas. Nothing super fancy by any stretch of the imagination, but you know, last year I did a bunch of kind of prototypey retread type games. This year I'm thinking, especially with Basecode, I would like to look at just making a really simple but new, unique game, something that maybe I could put in Steam. And again, to set expectations here, this is not in any way going to be like AAA or anything like that, but I think it's still, I have some ideas that I think could be fairly decent. So, and then the other thing I would like to do, and I recently started tinkering with this again, is once I get the Bootstrap compiler pretty solid and all of this stuff is working, you know, the game project we talked about, I would also like to revisit the Raspberry Pi arcade kernel kit, and I would like to use that as a test case for a more constrained embedded test case for Basecode. And also would be an excuse for me to have to, you know, add support for ARM. Yeah, and I would like to this time approach it. I mean, I think it would have all the same stuff it had before, but I want to support the hardware more broadly. And like, I want to take advantage of the GPU. I want to take advantage of all the cores. Yeah, so I would like to revisit that. And that I do see as something I would probably try to stream, maybe not every day, but much more frequently. So yeah, those are kind of my rough plans so far this year. And yeah, so should be fun and exciting. Any other questions, comments, rant requests? I haven't ranted in a month. I watched your latest stream, Cyanox. I watched the video of it. You were working on debugging that one. I guess it was a race condition, right? So, because your logging system, if I remember correctly, it was something was timing. I don't remember what the resolution of that was, but I remember watching it. So, yeah, you know, I don't really have too much to rant about, I guess. Although I am seeing a lot of, I guess I shouldn't say a lot. I'm seeing more, let's put it that way. I'm seeing more stuff like Hacker News, Reddit, where it seems like outright age discrimination seems to be much more prevalent. Hey, Slayer Darth. Oh, I shaved. Yeah, I shaved. I'm lazy. I don't want to shave. Then I grow a beard. Then the beard starts to bother me. And so then I end up shaving again. Yeah, I'm just noticing more, and maybe it's just because I can't remember who said this, right? But maybe it's just because I'm looking for it or I'm thinking about it. So I keep seeing it, right, in the media, and it's not always like the headline is not always related to age discrimination, or like that's not always even the main topic, right? Typically it's like how screwed up interviewing is for software development jobs. And you have the typical, arguments, people who think whiteboarding is wonderful, people who think whiteboarding is horrible, in every which way in between. But yeah, I'm seeing more of that, and I'm actually, I've actually talked with people who are actively looking, and I'm just noticing a lot of strange goings on, I guess, in that space where, yet again, if the shortage were truly a shortage, you would not expect the behavior. So yeah, good old Jim Butterfield. His books were go-to sources for me back in the day. All right, everybody. Well, thanks for tuning in, and I will probably schedule another one of these for probably a couple weeks out, and then another. I'll probably try to do them every couple weeks. Yeah, so like the 22nd, and then we'll do it again on like March 8th or something. So, and like I said, I have some other YouTube-y type content that I'm going to try to get out in the in-between. And yeah, very soon, very soon. You hear that? Get it done. I think the Bootstrap compiler is going to be pretty close. So, and it'll be stable and as performant as I'm willing to invest in the Bootstrap compiler, because of course I got to do it all over again. So, but yeah, it'll be good. I'm excited. I actually can't wait I want to actually start writing programs with it at this point. I'm kind of chomping at the bit. So, I keep telling myself that. Anyway, thanks everybody for dropping by. I'm still around. I will try to put something on the event schedule for a couple weeks out, and I'm usually on my Discord server. So if you're missing and you want to chat, or you want me to rant on Discord, I can typically do that pretty well. Join the server. And otherwise, everybody have a great weekend, and I will keep you all updated. Oh, one quick question for you guys. I created the event, on Twitch. Do you guys get notified, if I put an event out there? Or does Twitch not do that? Okay, so you did get notified. All right, good, perfect. All right, because I'll keep using that to kind of give everybody a heads up on when I'm planning and I'll paste it to the Discord for folks that don't use Twitch. And if I can hold my nose long enough and type at the same time, I'll put it on Twitter. I'm kind of disgusted with Twitter at the moment. But anyhow, all right, everybody. Thanks so much for dropping by, and I will catch you all later. Bye.